Yes, so can you hear me? Great. So, yeah, I am Haraken. So, welcome everyone to the BlinkOn Lightning Talk session. So, day two. So, yesterday's session was in person, and today's session is pre-recorded. So, by the way, so this is not a pre-recorded video. So, I am speaking so in real time. So, if you are skeptical, so you can ask me any easy question in the text chat. So, I am happy to answer. So, all right. So it's time for a party popper. So, however, it's 2 a.m. in Tokyo, and I need to be careful not to create a big noise. So instead of using this party popper, so today I prepared a Japanese version of a party popper. So this one is silent. So I can show you so how this works. All right. 1, 2, 3. Blink on. Amazing. So this is saying congratulations. All right. So today, so we have 10 lightning talks. So these are pre-recorded videos, but some of the speakers are joining remotely and watching this session. So please send a heartwarming message and emojis in this text chat. All right. So in that case, so let's get started.
Hi, my name is Kira Sievers, and today I'll be talking to you about our proposal to partition visited links history. As an introduction, you may be familiar with the visited CSS selector. It allows software developers to style visited links differently than those that the user hasn't visited. And what this causes is actually a few privacy issues because inherently we are exposing to bad actors user browsing history that they wouldn't already have. So our goal with this proposal is to improve user privacy by getting rid of those leaks. As some background, this has been an exploit that's known about for about 20 years. We are standing on the shoulder of giants, people who have tried many different methods of solving this ever-evolving issue. And broadly, I've categorized these attacks into 4 different categories: user interaction attacks, timing attacks, pixel color attacks, and process level attacks. So as you can see, there are many different ways that this exploit can take advantage of this difference between visited and unvisited links. Our proposal here is to partition. And what does that mean? And what does triple key partitioning mean? So the goal here is that if a renderer styles a link as visited, it will do it if and only if we had visited that link from this top level site in frame origin previously. What that means in practice is we navigate to a new site, say foo.com, we are parsing the CSS, and we come across a link. The renderer will put together that information, the link URL, top level site, and frame origin as the partition key, send it to the backend where it checks the database, and if and only if it completely matches that key that we've seen before, it will be rendered as visited. What are the privacy benefits of doing triple key partitioning as the solution here? Well, first, it renders the timing and user interaction and pixel color attacks that I spoke about before useless. And it does this because in the current model, if you go to search.com and you search for private, click on private.com, any site that embeds that link to private.com will be able to see through these exploits that I mentioned that you've visited it. But after partitioning, it takes into account that top level site. So it notes that it was on attacker.com. And previously you didn't click on private.com on attacker.com, you clicked on it on search. So what it means is that the partition keys are no longer identical, they no longer match, and so they'll no longer expose that information to attacker.com. Why by top level site? This prevents cross-site tracking. And so what this means is that we embed the same 3P iframe across many different top-level sites, and they can't share that information, so no cross-site tracking. And then why by frame origin? To uphold the same origin policy. So it means that embedders can't leak into embeddees and vice versa. Ultimately, we would love to hear your input, any thoughts that you have on this. We're still in the implementation and experimentation phase, so please feel free to reach out on our explainer, which is called Partitioning Visited Links History, in the Blink Dev thread. Basically, anywhere we would love to hear your input. Thank you very much. Have a great day.
Hi, everyone. I am Lu Huang from Microsoft Edge. We have been working really hard to make multi-origin web apps a reality, and I'm pleased to share our progress with you. First, let's review why scope matters. A web app can define its scope in a manifest to indicate what content should be experienced in the app context. And currently, an app scope can be no larger than the whole origin of the manifest URL. Let's look at YouTube as an example. If we look at the manifest, we can see that it uses a relative scope, and its effective scope is everything on youtube.com. The YouTube video is in scope, while the Google sign-in page is not within scope. The problem we found with how scope currently works is that it does not allow app content to span multiple origins. So many apps started as sites that span multiple web origins, and it could be very difficult for these sites to restructure their content's URLs. So let's look at a couple of really interesting examples here. In the Pinterest app, if you are redirected to the .ca top-level domain, the document would appear to be out of scope. In the Wikipedia app, if you wanted to read an article in a different language, let's say, the document now also appears to be out of scope. So there are some problems with app content being treated as out of scope by the browser. What we've designed and now implemented is a new field in the app manifest. This new field called Scope Extensions allows the developer to declare the origins that should be considered within the app's scope. In return, each participating origin needs to agree to being part of the app by specifying its app ID in a well-known configuration file. So only origins that the app directly controls can be presented as in-scope content. We've also done work to protect the user. So periodic revalidation is done to ensure that the scope extensions are still valid. Origin animations in the title bar keep the user aware of their browsing context. Storage and permissions are still fully separated by origin, and the app settings page lets users inspect scope extensions. This work is now implemented behind a feature flag, and we're planning to start origin trials in the M120 timeframe. We are really looking forward to your feedback. Thanks for listening.
Hello, my name is Sam Davis Omeka Jr., and I'll be presenting on color providers in the renderer. First of all, forced colors. Forced colors mode is an accessibility feature aimed at improving readability for low-visioned users through contrast colors. Currently, there are two ways to trigger the state in the browser. One, through Windows High Contrast setting. Two, through emulation via the DevTools feature. We started work to introduce a third way to control the state via a browser setting, which gives users more control over this feature and makes it available across different platforms and not just Windows. Also, users can opt out of forced colors mode for specific sites if they prefer. However, because the forced colors state is stored in the native theme, we needed a way to access the forced color state per frame. This also coincided with work being done to deprecate the native theme as a source of color in favor of color providers. Prior to color providers, there were mainly three ways to access color in Chromium: the native theme, the theme provider, or just directly specifying colors. This led to disparities and hard to trace bugs relating to color. With the introduction of color providers, the aim is to unify and centralize color access through these providers. Simply put, color providers are objects that supply color information for elements. So, step one saw us move the first color state to the color pipeline, which involved number one, having color IDs for elements, number two, having a color provider key, which depicts the state of first colors we're in, and number three, having a mixer that provides color definitions depending on the first color state. This was all well and good until we discovered in the renderer, color providers are stored in Blink web theme engine, and this reflects the global theme. This is fine for most cases, but in the case where a single renderer can hold multiple web contents, we experience undesired outcome. Furthermore, to support the block list feature would need providers to exist per page. This saw us do a huge refactor for color providers to exist in Blink page. And also, given that frames of web contents can live in multiple renderers, we use something called page broadcast to propagate color provider colors to all frames associated with a given page in all renderer processes. In conclusion, moving the first color state to the color pipeline and having color providers exist per page brings us closer to our ideal scenario. The next step would see us using these providers to paint and fully deprecating the native theme as a color source. Thank you. Please reach out if you have any questions.
Hello BlinkOn, Diego here from the Microsoft Edge team with some pretty groovy stuff for you. The concept of applications on the web is already a reality. Call them what you want to call them. Home screen apps, web apps, progressive web apps. Take a minute to pat yourselves on the back. We've made it. Applications built entirely with standards web technology are already being prompted for installation on browsers near you and present in almost all of your favorite stores. Yay! Now, with great apps, we need great distribution. There are ways that you can install apps or websites that you're currently using. Think add to home screen, add to dock, and the almighty PWA install. But the platform can't do this for applications that are not on the same scope. This prevents online application repositories and limits the frictionless discoverability that we all love from the web. So let's fix this and let's bring installation to the web. At Edge, we are working on explaining, speccing, and prototyping an extension to the Navigator interface that takes the shape of a promise-based method that has the ability to install same and cross-domain websites. It's pretty exciting. How would it look? More or less like this. The method would receive a manifest ID and then prompts to or adds the application to your device. This would follow the browser's install flow. It then resolves if the installation was successful or it would reject otherwise. And what can be installed? Basically, what the implementer deems as acceptable. This can vary with site or app quality and certain checks, but this is not very different from what's already happening in the browser today. And of course, we want to make it safe. So requiring a user gesture, a new permission type, a new field in the manifest file, and the user agent's install confirmation. It's all designed to enable the capability while avoiding potential installation prompting spam. Similar to how we want to enable websites to install other web apps, we also would like to enable installed web apps to understand how they got installed. We've published a proposal for a new acquisition info API that does exactly that, and we're seeking your feedback. We see this API benefiting web apps that are installed through the store on a device, as well as for those that are installed in the browser via the Web Install API. In this example, we can tell from the install source property that the web app was installed from the Microsoft Store, and we're able to retrieve associated information from that install source, like its campaign ID. For a browser-installed web app, the install source will identify the origin that initiated the install, along with when it was installed and any other information that the install source chooses to pass along in its Web Install API call in the form of a parameter. We'd love to hear from you regarding your potential usage scenarios and any other ideas for improvement. Please be in touch and let us know what you think.
Hi, I'm Stanley. I'm a software engineer at Microsoft, and we've been working on improving system media controls in Chromium. First, a quick reminder of what PWAs are. They are a web standard way to install websites onto your device, given that the website meets some criteria. In this talk, we'll be focusing on desktop PWAs, also known as DPWAs. PWAs present to the operating system like independent apps, but under the hood, they still depend on Chromium. One of the selling points of PWAs is that it's comparable to that of a normal application on the operating system. Here on Windows 11, you can see this Chrome PWA has its own desktop shortcut, shown here, taskbar icon, shown here, and jump list UI, shown here. PWA OS integration doesn't end here, but the point is that PWAs are meant to seem like standalone applications. Next, let's talk about system media controls. This is what system media controls look like on Windows 11. This UI is presented by Windows when you click on the clock volume area in the bottom right. Its purpose is to allow you to see what is playing and control it even if you're doing something else. So what's the issue? As we discussed before, Windows sees this YouTube PWA as an independent app. However, notice the System Media Controls UI still shows Chrome as being the application that is associated with the audio, shown here. This is because Chromium does not differentiate where the audio is coming from and surfaces all audio information through the same instance, whether the source be PWA or browser. To make matters worse, if you have more than one audio source from Chromium, say a browser tab or a PWA, they will fight over who gets to present information to the OS. So now, onto a solution. Most operating systems provide a way to control multiple playing sources. In Windows 11, you can cycle through different apps. Here, I can click on this button here, and it'll cycle through to the next app. The idea for our work is to enable DPWAs to leverage this pattern and present each DPWA separately to the browser. Currently, we're working with Chromium owners to design the best approach to solving this problem. Our goal is to deliver this feature in the coming months before the end of the year. Following that, we'll be looking at doing the same on macOS, which has similar UI surfaces to Windows. If you have any questions or want to learn more, feel free to reach out to any of the contacts on this page and we'd be happy to help. Thank you for your interest and attention.
Hello, I'm Byung-woo from Igalia. Igalia has been diving into some cool stuff that solve issues in the content filtering field, like the head pseudo class and DNR update static rules API. Now we are investigating issues with the content scripts extension API and DNR regular expression filter. Today, I will give you a quick summary on our exploration of the DNR regular expression filter in Manifest v3. The DNR regex filter attribute lets you specify a pattern to match against the network request URL. In Chrome, it is implemented by using the RE2 library. And this causes a couple of issues. First, there are syntax differences between regex filter and JavaScript patterns. It's not a big deal since the API document briefly mentions it. The second issue is memory limitations. Chrome limits a single regex filter to 2 kilobytes. Due to this limitation, some filters that were valid in Manifest v2 are now invalid in v3. The limitation policy is associated with the RE2 instance creator API, which lacks a way to set an optimal memory budget for regex patterns. To address this, we investigated RE2 logic. We explored how budgets are allocated, what is the optimal case, and when memory errors occur. Our investigation led us to a potential solution, adding a step to turn a non-optimal allocation into an optimal one. This would enable Chrome to set optimal memory budget for each regex filter. Then we can increase the limit for each filter. To test this concept, we made patches for both the RE2 and Chromium projects. By increasing the regex filter limit from 2 kilobytes to 30 kilobytes, we boosted the coverage from 61% to 97%. And we loaded 93% of collected regex filters without changing the 2 megabytes limit for each rule source. However, it is not all positive. We need to introduce a new create option in RE2 and update a flat buffer scheme in Chrome. And explaining conditions for exceeding the 2 megabytes limit won't be easy. So we are going to share our progress to an existing W3C issue for feedback. If you have any doubts, questions, or ideas, please reach out. Thank you for your time.
Hi, I'm Claire from the Compositions and Animations team at Microsoft, and I'm here to talk about composited clip path animations. In a nutshell, this feature uses native paint worklets to move clip path animations to the compositor thread, like which has been done with composited background color animations. To explain the motivation behind this feature, let me quickly show a demo of what it's like with the feature off. When the main thread is busy, as I've simulated in this example, there's a highly visible stutter in the boundary of a clip path This is quite visually jarring. The main difficulty in implementing this feature is that the CC animation logic doesn't actually know how to interpolate between path values. So what we do is fall back to a mask image-based clip using a paint worklet. During paint, all the animation keyframes and keyframe timing functions are packaged into a paint worklet input, which is shared to the CC thread. During a compositor frame, the paint worklet will take a dummy float value animated on the compositor and interpolate these stored values together. From there, we can generate a series of paint operations to create a mask image, just like we would on the main thread. And here we can see the feature working. As you can see, the animation on the right, which makes use of the feature, is much smoother than the animation on the left, which does not. We're hoping to land this feature in 121. I'd like to lend a special thanks to everyone who helped us along the way, and of course, thank you all for listening.
Hi, I'm Zakhar from Galia, and today I'm going to talk about the Volvic Chromium backend. Volvic is a browser for XR developed by Galia. It supports the Android-based devices and was originally implemented using GeckoView as the browser backend. We are currently in the process of integrating a Chromium backend based on Content API. Before starting to work on the Chromium backend, we had to decouple the browser engine-specific code from the rest of the code base. We ended up designing an API to communicate between Volvic and the underlying browser engine, which allowed us to share most of the Volvic code between Gecko and Chromium, and most importantly, all of the platform-specific code. We had other attempts at introducing a Chromium backend based on WP and WebLayer, but they were abandoned in favor of the Content API-based solution. Most important reasons for that are flexibility, good performance, and Android support. However, there are some downsides like the amount of code required to get started and the fact that your solution has to live inside the Chromium tree. To begin our Content API-based implementation, we first created a Chromium fork called Volvic Chromium, then implemented a shell similar to other shells like Content Shell, App Shell, or Chrome, and finally added some JNI interfaces to allow our shell to communicate to Volvic. We built Chromium content layer, parts of Chrome UI, and our custom code as an AAR library to be included by our Volvic Android project. To display the actual browser window, we use the Android Surface class as a canvas for WebView. The instance of Android Surface is created by Volvic and passed to Volvic Chromium, where it's used by our modified version of the Content View class to display the web contents. The biggest feature for any XR browser is the WebXR support. Chromium supports several XR platforms like OpenXR, AR Core, and GVR. However, we opted to rely on Volvic's existing WebXR implementation, which is shared between Gecko and Chromium, because it will allow our Chromium backend to support the same hardware as the Gecko backend. So we introduced a new WebXR platform to our Chromium fork called WVR, which supports our existing multi-backend API and uses shared memory to communicate with Volvic efficiently. We currently use texture mailbox as a transport method, but we are also working on the hardware shares buffer support. There's a number of other features that are implemented by the Chromium backend, like navigation, user input, incognito mode, and so on. We're getting close to being on par with the Gecko backend in terms of functionality. Most of the WebXR content and 3D video content is supported, but there are still some bugs. Performance of Chromium backend is better than the Gecko backend, and overall we're getting close to releasing the first versions of Volvic based on Chromium. Thank you for your time.
Hi, I'm Jason Robbins from Google, and I'm going to talk about streamlined feature reviews on ChromeStatus.com. For anyone not familiar with Chrome Status, it's a web app that tracks the development of new web platform features. The homepage is a roadmap that shows what is launching in each milestone. Another section of the site displays usage metrics. And if you drill into one of the feature detail pages, you get all the information that we have on that feature. But since you're attending BlinkOn, you're probably not just observing how features are launched. You're probably involved in developing them. Chrome Status is the official tool support for the Blink Intense process. It helps guide you through that process and shows you where you need to coordinate with other teams. Today I'll focus on the reviews. Sometimes getting the approvals that you need to launch a feature can feel like this cartoon. The joke is that each one of the reviewers is ready to swat down your feature and send you back to the drawing board. The truth is that the reviewers are on your side, so I flipped them around. Each of the review teams is waiting to boost your feature by adding their expertise to make it a success. This slide shows the refinement that we made to the Blink Intents process. It used to be that the API owners were the only explicit review role in that process. In many cases, cross-functional teams also contributed, but they weren't looped in, so their feedback often came too late and seemed ad hoc. The arrow shows the change we made. Consulting with cross-functional teams sooner allows them to boost the launch in a more systematic way. It gives the API owners more context for their review, and it makes it more likely that the feature launch will lead to a solid landing. Here's what that systematic tool support looks like on Chrome Status. Feature entries are divided into stages, and each stage has gates for reviews by the relevant teams. Feature owners can request a review and get a sense of how long it will take to get an initial response. Starting from milestone 118, we're asking feature owners to loop in cross-functional teams before starting an intent thread. For example, the testing gate provides a list of questions that help you determine whether your feature has enough test coverage to be ready to launch. Reviews are now live, and we're continuing to improve Chrome Status to help you help move the web forward. Feel free to give us feedback through our File and Issue link.
Hello, Diego and Ivan here from the HPWA team. We'll give you a quick preview of some fixes we're doing to bridge the gap between PWAs and native apps. The problem we're trying to address is that installed PWAs can end up with long repetitive text on their title bars due to bad dev practices when using the title HTML tag. For instance, when browsing to a specific post on X, previously Twitter, the PWA ends up with a long truncated text in the title bar that doesn't look polished nor on par with native clients. Our solution is to change the source of the text in the title bar from the HTML title tag to a complementary piece of information that better adapts the content of a running application. For example, when navigating through the app, you can update the app title to reflect what you're trying to do, like reading your direct message or scrolling through breaking news. As a bonus, we're adding the app icon to the title bar to match the look and feel of other inbox native apps on Windows. And now, a quick demo. This is a sample web app to demonstrate the new app title feature for PWAs. I have DevTools open to show you all the ways you can change the app title. You can see that it has app title set to app title as the content of the meta tag. Updating the app title meta tag will change the title of the window. We can also change app title via script. First, I'll change the app title value, and you'll see it reflected in the title bar. Next, I'm going to remove the app title meta tag, and you'll notice window title is reset back to the title of the page. And finally, you can also add app title dynamically via script, and its value will be reflected. If the app is navigated as a normal web page, we can see that the window title comes from the title tag. Even though we have the meta tag with an app title, it will only be used on PWA window. And that's the end of the demo. Thank you.
All right. So thank you very much for many amazing updates. So I am very excited to have many speakers from Microsoft, Igalia, and non-Google organizations. So please send another round of applause to all the speakers. So thank you very much. Great. So that's it for the lightning talk session. So see you again at the next BlinkOn. Yeah, thank you very much.